Hello friends, welcome to the next session on neural network. Today we'll talk about recurrent neural network. So before starting with recurrent neural network, let's talk about auto completion by Google. So what Google does, whenever we are typing something, it automatically gives you the suggestion and tries to complete the sentence. So how does it work? So it has a collection of large volume of most frequently occurring consecutive words stored in a database, right? So the input to this Google auto completing feature is a large volume of most frequently occurring consecutive words in a database. Then this data is fed to a recurrent neural network. And what recurrent neural network does, it analyzes the data by finding the sequence of words occurring frequently and builds a model to predict the next word in the sentence. Right? For example, if I'm searching for Kolhapur is famous for, automatically I get a suggestion below saying Kolhapuri chappals, right? So what it is? It is an auto completion of the sentence. What Google does is automatically. The same way Google Assistant also works. Let us take another example. Suppose we are given a sentence, let us say, famous chappals Kolhapur for Kolhapuri is, again I repeat, famous chappals Kolhapur for Kolhapuri is. Did this make any sense? No, no. Why? This sentence sounds irrelevant. What is the original sentence? Original sentence is Kolhapur is famous for Kolhapuri chappals. This makes a perfect sense, right? But when we read the first sentence, famous chappals Kolhapur for Kolhapuri is, what happens? Our mind is also confused to understand the sentence, right? When we as a human being, the brain gets confused, then what about neural network? Right? So I'm sure neural network will have tough time deciphering such text. So there are many such tasks in everyday life which gets completely disrupted when there is a sequence, when the sequence is disturbed, right? So there are multiple such cases wherein the sequence of information determines the event itself if you are trying to use such data for any reasonable output. So what we are trying to do, we need a network which has access to some prior knowledge about the data to completely understand it. That means when I'm typing Kolhapur is famous for, that means it has some data stored already related to that sentence which has Kolhapuri chappals in it. Right? So there's a need for neural network dealing with sequences, and for this what we have is a recurrent neural network. Now, when we talk about feed forward neural network, we already studied in the previous lectures, we spoke about issues in feed forward neural network. Now, why we are going for recurrent neural network? As per the examples, what we discussed in the beginning, it is to process the sequential data. Now, what were the issues with feed forward? It cannot handle sequential data, as we have taken an example of XOR, single input, it is given and then the output is predicted. Considers only the current input, cannot memorize previous inputs, does not have any memory associated with it, so it cannot remember what was the previous input. So to handle sequential data, solution is what? We go for recurrent neural networks. Now, in short, we'll be calling it as RNN. And RNN can handle sequential data accepting the current input data and previously received inputs. Remember, current input data and previously received input. So it has current as well as previous input data. It can memorize previous inputs due to their internal memory, which is not there in case of our feed forward. So RNNs are designed to take a series of input with no predetermined limit on size. We can process any long sentence here, right? A single input item from the series is related to others and likely has an influence on its neighbors. See, when we talk about a sequence has the sentences which are related with each other. Now, when I'm saying Kolhapur famous, so famous and Kolhapur has some relation which tells, okay, Kolhapuri chappal. Recurrent neural network remembers the past and its decisions are influenced by what it has learned from the past, that is the previous knowledge. It follows a recurrence relation instead of a feed forward pass and uses back propagation through time to learn. Now, recurrent relation, as far as MSc students are concerned, we already spoke about it in the previous semester. But when we write recurrence relation to solve the complexity of recursive algorithms. So what recursive algorithm does, once you give an input, it gets execute, and the output of that execution is given as input to call the function again. So just remember, recurrence relations are the base for recurrent neural network. Here the output from the previous step are fed as input to the current step, right? Output of the previous step. As I said, in case of recursive algorithm, suppose when you calculate factorial of 5, so first you calculate factorial of 1. So output of factorial of 1 is an input to calculate factorial of 2. Fine. So RNNs can take one or more input vectors and produce one or more output vectors. And outputs are influenced not just by weights applied on inputs like a regular neural network, but also by a hidden state vector representing the context based on prior inputs slash outputs. Why we are saying inputs and outputs? Because output of one will become input of the other. Now, same input could produce different output depending on the previous inputs in the series. Remember the context when you're putting the data in a sequence. The main and the most important feature of RNN is hidden state, which remembers some information about a sequence, which is nothing but the memory. So feed forward neural network, or if we take an example of multiple perceptron model, that has more number of neurons but only single hidden layer. Now when we can consider more number of hidden layers, then it becomes our deeper neural network. Now if you can see here, we have 3 hidden neural networks. So here input layer receives an input, right? First hidden layer activations are applied, and are sent to the next hidden layer, and then successive activations are applied and sent to the further hidden layer, and then ultimately the output is produced. Now, to look at it, the diagram carefully, each hidden layer has its own weight and bias. You can see for hidden layer 1, we have W1 as weight and B1 as bias. And similarly, for each hidden layer, they have their own weight and their own bias. Hence, each of these layers behave independently and cannot be combined. Why independently? Because it has its own weight and bias. This also has its own weight and bias, its own activation. So they are independent of each other, right? Now, if you want to combine all these hidden layers together, then what is required? You need to have same weight and same bias at all the hidden layers, fine? So that is nothing but we'll be talking about recurrent layer to combine all the hidden layers into a single layer. So RNN convert the independent activations to dependent activations by providing the same weight and bias. Let's just see now, it's not W1, W2 anymore. It is just W and it is just B. That means same weight and same bias. Now this reduces the complexity of increasing parameters because now the parameters are increased. Now here they were 2, right? Out of 6, now they reduced only to 3. Fine. And memorizing each previous output, right? Memorizing each previous output to the next session input, right? So given to each output as input to the next hidden layer. So this one's output is input to this one's output is input to this. Now these 3 layers can be joined together such that the weights and the bias of all the hidden layers is same, and you can put it into a single recurrent layer. So all these hidden layers can be rolled in together in a single recurrent layer, right? So we can see here, all these 3 hidden layers are rolled into a single recurrent layer, or you can say single recurrent neuron. So at all the time steps, weights of the recurrent neuron would be same since it's a single neuron now. Fine, all the weights will be same. So recurrent neuron stores the state of a previous input and combines with the current input, thereby preserving some relationship of the current input with the previous input. Fine. Why? Because output of one hidden layer is input to the other hidden layer. So there is a relationship between input and output. Now RNN have a memory which remembers all information about what has been calculated. So it uses the same parameters for each input as it performs the same task on all the inputs or hidden layers to produce the output. As we saw, the weight and the bias was same for all the hidden layers. So it uses same parameters. This reduces the complexity of parameters unlike our normal neural network. Now, the recurrent neural network consists of multiple fixed activation function units, one for each time step, right? It has multiple but fixed activation function units, one for each time step. Now, each unit has an internal state, which is called the hidden state of the unit. Now, this hidden state signifies the past knowledge and the network currently holds at a given time step. Right? It has the past knowledge as well as the current knowledge. So this hidden state is updated at every time step to signify the change in the knowledge of the network about the past. Right? So how it is checked? The hidden state is updated using the following recurrence relation. Here you have the new hidden state is calculated using a fixed function with the trainable weights, right? And the parameters to this function is the current input and the old hidden state. We can say this is current and t minus 1, that is previous or the old state. The same way what we do in case of recursive algorithms. Now, how do we calculate the current state? So again, you have current state is equal to function applied to previous state and input state. Okay. Activation function what is applied is tangent hyperbolic function. We also call it as 10h. Right. So again, this is new hidden state, the activation function, tangent hyperbolic function. Then you have weight at recurrent neuron, right? Previous state ht minus 1, right? And this is now weight at input neuron, and this is input state, right? So activation function is applied to this, and which ultimately gives you the new hidden state. Now, how do you calculate the output? For calculating the output, again you have y, right? Yt, this is the output. Now weight at the output layer multiplied by the new hidden state. But we saw already how to calculate this new hidden state. Now, how do we train our RNN? A single time step of the input is provided to the network. Then calculate its current state using the set of current input and previous state. The current ht becomes ht minus 1 because the current state becomes previous state for the next time step. One can go as many time steps according to the problem and join the information from all the previous states. Once all the time steps are completed, the final current state is used to calculate the output. Fine. The output is then compared to the actual output, that is target output, and the error is generated using our loss function. The error is then back propagated to the network to update the weights, and hence the network is trained. So after calculating the error, whatever is the change, the weights are changed, and again it is fed back to the input layer. A recurrent network feeds its outputs back into its own inputs. This means that recurrent network, the activation level of the network, form a dynamical state that may reach a stable state or exhibit chaotic behavior. What does this mean? In case of recursive algorithm, we always give a base case so that it can come out of the recursion. That is stable state, right? And sometimes whenever we write a recursive algorithm, it goes into an infinite state, infinite loop that is nothing but executing a chaotic behavior. Moreover, the response of the network to a given input depends on its initial state, which may depend on the previous inputs. Hence, recurrent networks, unlike our feed-forward networks, can support short-term memory because it can remember the state of its previous. This makes them more interesting as model of the brain, but also more difficult to understand. So what are the applications of RNN? So before going for applications, let's talk about RNN again. What RNN does, it takes an input, right? The hidden layers are combined into a single recurrent layer, or you can say a recurrent neuron, where it has number of hidden layers. The input is given to the hidden layer after being the processing activation function, applying activation function, the output is again fed as input to the next hidden layer, right? This series continues till the output is generated. Once the output is generated, it is checked for the errors, like whether what we expected it is same or different. If it is different, then the weights are updated and again the input is fed back to the network. So the same process is again repeated. Okay. So now what are the applications of RNN? The very first application is image captioning. RNNs are used to caption an image by analyzing the activities present. That means once an image is given, it can give a caption to that image. By just analyzing that image, it can generate a caption. Time series prediction. So any time series problem like predicting the price of the stocks in a particular month, you can use RNN there. Natural language processing. Text mining and sentiment analysis can be carried out using an RNN for natural language processing. When we talk about sentiment analysis, whenever you're writing your paper or whenever I'm delivering my lecture, now listening to my lecture or the way I write my paper, I can understand what was the sentiments involved when you're writing something on the paper. Next, what you have is a machine translation. Given an input in one language, RNNs can be used to translate the input into different languages as output. You can see the translators. Once you speak in English, it can be translated to any language, or even from Hindi, you can get it translated to any language. There are 4 types of RNNs. First one is one-to-one RNN. In this type of neural network, we also call it as vanilla neural network. It is used for general machine learning problems. It has a single input and single output, right? Single input and single output. One-to-many RNN, this type of neural network has single input and multiple outputs. So an image, an example of this is an image caption. So what is input? Input is image. What is output? Output is a sentence giving a caption to that image. So input is single and output is multiple. Many to one RNN. This RNN takes a sequence of inputs and generates a single output. Sentiment analysis is a good example where a given sentence can be classified as expressing positive or negative sentiments. Now, after listening to this lecture, you might give a comment. So that comment will be an input because it has multiple words, right? Output will be what? Whether the comment is positive or the comment is negative, right? So many to one. Many to many RNN. This RNN takes a sequence of inputs and generates a sequence of outputs. So machine translation is one of the example because you give the whole sentence as input and the output is again the whole sentence in a different language. Okay, so what are the advantages? An RNN remembers each and every information through time. It is useful in time series predictions only because of the feature to remember previous inputs as well. This is called long short-term memory. Recurrent neural networks are even used with convolutional layers to extend the effective pixel neighborhood, especially in case of image processing. So everything which has advantage also has some disadvantages. So here the main disadvantage is gradient vanishing and exploding problems. This will look at it in the next slide. Training an RNN is very difficult task, right? Because there are so many hidden layers, you don't know where the problem is. It cannot process very long sequences if using tangent hybrid function or rectified linear unit function as an activation function, right? Now, gradient vanishing and exploding problems are what? RNN suffers from problem of vanishing gradients. Gradients, I have one full lecture uploaded. You can go through it before going through this. So gradients carry information used in the RNN, and when the gradient becomes too small, the parameter updates become insignificant. What gradients gives you the minimum change what is required. So this makes learning of long data sequences difficult. The next problem is exploding gradient problem. While training a neural network, if the slope tends to grow exponentially instead of decaying, this is called an exploding gradient. So this problem arises when large error gradients accumulate, resulting in very large updates to the neural network model weights during the training process, right? Because after accumulating all the error gradients, updation of the weights is difficult. Long training time, poor performance, and bad accuracy are the major issues in gradient problem. So what is the solution? Solution is long short-term memory network. Of course, we'll not be talking about this. This is an assignment, what you need to work on it and submit it as a tutorial. I hope the short introduction to recurrent neural networks is clear. Fine. Before going through this video, I expect you all to go through all the videos related to neural network. Thank you. Stay home, stay safe.